Okay, I'm going to go about working this equation, solving this equation. And of course, when I say solve, I'm trying to find the value for the variable x. So I'm going to work this two different ways. I'm going to first work it in a manner that is something you are familiar with, or most people would approach it this way. I'm going to give you an analogy or analogous equation. So 3x plus 7 equals negative 4. This is not the same equation, of course. I'm just showing you something to show you that really it's the same irrespective of whether there's fractions or not. So for the equation in white, the first thing I'm going to do is I'm going to subtract 7 from both sides. Now, plenty of students think of this as moving it to the other side or whatnot, and I think of it as I want to make this into a 0. Why do I want to make that 7 into a 0? Because after I'm done, I want it to be 3x. So 3x plus 7, I have to get rid of that 7 somehow. I need to turn it into a 0. So that 7 means it's a positive. I have to subtract 7 from it. That then tells me that I have to do this also on the other side of the equation. The negative 7 has to be applied to both sides of the equation. So this becomes a 0, and I get 3x on the left. Negative 4 minus 7. So I'm at negative 4. I'm going to move to the left 7 units. That's negative 11. And then divide both sides by 3. And I get x equals negative 11 thirds. Okay? This green equation is the same, except we have fractions, which means when I actually do the arithmetic, the subtraction, I have to do some extra work because it's a fraction. So again, the same thing. I want to have this when I'm done. That's it. This 1/2 is there, so I have to turn it into a 0. I know, again, some people like to think of it as moving it, but I'd rather think of it as I want to make this a 0, so I need to subtract that same value, the half, from the left-hand side. 1/2 minus 1/2 is 0. That leaves me with a quarter x on the left, or 1/4 x on the left. But I have to do the same action that I did on the left-hand side. I have to do that same thing on the right-hand side. So I have to also, subtract 1/2 from the right-hand side. What that means is I end up with minus 4, or negative 4 minus 1/2. Now, because 1/2 is a fraction, excuse me, I need to have common denominators when I add or subtract fractions. So to change the number 4, I'm not actually changing the number 4. I'm only changing what it looks like. To alter its appearance so that it has a denominator, I'm going to multiply it times the number 1. That number 1 looks like 2 over 2. This is actually the number 1. I cannot multiply a number in an equation, a single value in an equation, by anything other than the number 1. Otherwise, I change its value. Okay? And that breaks the equation. It changes the equation altogether. So I'm choosing to multiply negative 4 by the number 1, but that number 1 looks like 2 over 2. What happens then? This negative 4 is really negative 4 over 1. Every integer is a fraction or a rational number. And then I multiply across. So negative 4 times 2 is negative 8. 1 times 2 is 2. And I didn't do anything with the minus 1/2. So notice this is still the number negative 4, because negative 8 divided by 2 is negative 4. It just looks different. It looks like negative 8 over 2. But this allows us to see that there are negative 8 halves, and I'm going to subtract another 1/2, which means altogether I have negative 8. I'm going to subtract another 1, so I'm going to have negative 9 halves. Most of you will divide the left-hand side by 1/4, mostly because you're taught to do the opposite operation with the same value. So I'm multiplying x by 1/4, so I'm going to divide by 1/4. If you choose to do it this way, it's perfectly fine, nothing wrong with it. I'm going to show you an additional way. I have to divide both sides by 1/4. Otherwise, my equation doesn't remain the same statement. The statement changes. On the left-hand side, again, I think of it as I'm choosing to divide by 1/4, not because it's the opposite operation with the same value. I think of it as because I want these to divide and become the number 1. When they become the number 1, I have 1x. And what is 1x? 1x, or 1 times x, is simply x. And that's what my goal was. Now, when dividing these two fractions, for many it gets complicated. Many of you, not all of you, many of you think this little mnemonic device. So keep, which means I'm going to keep this numerator, or keep the first number. Switch, which means change division into multiplication. And then flip, keep, switch, flip. Flip means take this and reciprocate it or invert it. Or in other words, 1/4 becomes 4. When I multiply these across, I get negative 36. And then 2 times 1 is 2, which means I get negative 18. Now, how would I have done this differently? So I'm going to go back here. And this is just another way. If you don't like it, don't do it that way. If you like it, then practice it. So I'm going back to this green spot, and I'm going to do it the way I prefer to do it. And it comes from back to this idea, or comes from the idea that I want to turn or change this 1/4 into the number 1. I want 1x or x. So how can I change 1/4 into the number 1? Well, yes, you could divide by 1/4. We already did that. What if I, instead of dividing by 1/4, I multiply times 4/1? Or what is called the reciprocal of 1/4, or what is referred to as the multiplicative inverse. So what is the multiplicative inverse? Every number has a multiplicative inverse. The multiplicative inverse of a number is that number which, when you multiply it, becomes the number 1. So in other words, 3/7 has a multiplicative inverse. That's the number 7/3. Why? Because when I multiply it, or the two values, I get 21/21, which is 1. Negative 5/9. Its multiplicative inverse is negative 9/5. And so that becomes positive 1. Okay? That's what multiplicative inverse is. Now, what's the multiplicative inverse of 1/4? Well, it's 4. The same way that we did the previously, if I multiply the left-hand side by 4, I must also multiply the right-hand side by 4. You choose this action, it forces this action. We can't control this side. So 4 times 1 is 4, 1 times 4 is 4, 4 divided by 4 is 1, and I get all the way down to here. Here, I'm just going to multiply negative 9 times 4, 2 times 1, and I get negative 18, which is the same thing that I got here. Why? Notice that this step looks the same as this step. Negative 9 halves times 4/1. Negative 9 halves times 4/1. If you like that, fine. Practice it if you're not used to doing that. If you're not okay with it and you want to rather do it the other way, fine. It makes no difference to me. Okay. So that's how one way to go to solve for that equation. You get x equals negative 18. Another way is to use a method called clearing fractions. Clearing fractions, let's write down the equation, just means I have to look for or determine what is the least common multiple. And really, I don't have to find the least, but it makes my numbers more easily worked with because they're smaller, they're lesser. So I want to look for the least common multiple of, I should write all of the denominators in my whole equation. Denominators. Okay, ran out of room. So for instance, when I say common multiple, that means that this number must divide the value I'm thinking about, and this number also must divide that value. Now, this one's pretty easy to see, but let's assume that we're fighting with this a little bit because it's new to us. Let's try to number 16. Does 4 divide 16? Now remember, when I say divide, it means it divides into it and there's no remainder. So does 4 divide 16? Yes. Why? Because 16 divided by 4 is 4. Notice how there's no remainder. There's just an integer. But that has to be true for all of the denominators. Now, yes, this term over here has a denominator of 1, but 1 divides everything, so we can mostly ignore that. But we have to check the 2. Does 2 divide 16? Well, the answer is yes, because 16 divided by 2 is 8. So this is a common multiple of 4 and 2. Is it the least common multiple? Like I said, it's not required that you have the least common multiple. It just makes the math a little bit faster, easier, because the numbers are smaller if I can find the least common multiple. Let's check. Let's check 8. Is 8 a common multiple? In fact, yes, because 4 divides 8 and 2 divides 8. Oops, I'm writing too fast. And so it is a common multiple. But again, it's not the least common multiple. What is the least common multiple? 4 is the least common multiple. Okay? So what do I want to do? Let's copy down the equation again. And get white. 1/4. I picked yellow, but it does not matter. Equals -4. And then we're going to use this least common multiple. We're going to multiply. You're used to hearing multiply both sides of the equation by some number. In this case, the least common multiple. I'm going to multiply. Oh my goodness. I'm going to multiply both sides by the number 4. Personally, I prefer to think of it this way. And some students were wrestling with this a little bit. I think of it as having to multiply every term by the number that I'm choosing. And if you notice, I'm going to go back again. If you notice, multiplying both sides by 4 is exactly the same, because once I distribute, I'm multiplying every single term by the number 4. You can even simplify this idea a little bit more. For me, I'm multiplying the whole equation by 4, and then I'm going to sort of distribute to every single term in the whole equation. So no matter how you think about it, every term is going to end up getting multiplied by that number 4, whether you think of it as multiplying both sides, multiplying the whole thing, however you want to think about it. Once I do that, I'm going to get 4 times 1/4 x plus 4 times 1/2 equals 4 times -4. That's 4. That's 4 when I'm multiplying them. That's 4. And that's 2. And this is -16. But what's 4 divided by 4? 1. 1 times x. X. What's 4 divided by 2? 2. And that's why this method is called clearing fractions. I can find this least common multiple, multiply the whole equation, or each term, or both sides of the equation by that least common multiple, and I clear all the fractions. And now this looks very much like this thing up here. I think of it as it being flat. There's no fractions. So now, in this particular case, all I have to do is subtract 2, because the coefficient in front of x went to 0. But that doesn't always happen. Sometimes you're going to have some number here, and you have to divide both sides. But that's clearing fractions. This is what I meant in class to multiply by a single value, or all terms by a value. But some folks are wrestling with that.